Today we are going to set up the bromination of acetanilide again, given that it failed the first time. The bleach solution had gone bad, and so the oxidizing agent was not present and the reaction didn't work. So I have three crops, the extra acetanilide from the original synthesis that I didn't use, which is 48A in my book, and then the two crops of recrystallized material, 49B and 59A, that came from the recrystallization of what should have been the brominated product. So I'm going to use all of those, but that only accounts for a total of 528 milligrams of acetanilide. So I'm going to have to supplement that by using the stock bottle of acetanilide and adding another 472 milligrams. But I'm going to start by dumping the entire contents of these three vials. And both 49B and 59A have a little bit of bromide product in there, but that's fine since bromide product is what we're actually trying to make. So we'll use up all the acetanilide that we have from previous reactions. And then we'll take the stock acetanilide and measure out 472 milligrams of it to make up to a total of 1 gram. Fortunately, we have some stock acetanilide, so I don't have to repeat the first part of the experiment. So we're just tearing a piece of weighing paper. And this material is not very pure, as you can see from the fact that it's kind of a gray solid. But hopefully that won't matter. And we'll be able to purify away any impurities. So I have 469 milligrams, 0.469 grams. That's good enough. I'll be a little less than a gram total acetanilide, but I'm not worried about it. So you can see how much nicer our material from recovered is nice white powder, and this is kind of gray flakes, but good enough. So we're going to want a stir bar in there. This kind of stir bar is the right one for that kind of flask, the oblong stir bar. And then we need to measure out 1.8 grams of sodium bromide. I'm just going to wipe off my little spatula and use the same spatula. But 1.8 grams of sodium bromide is a fair amount, so I'm going to use a little weighing boat for that. Probably be easier to transfer. Make sure there's just one. Yep. I have 1.792 grams. That's close enough to 1.8. Doesn't have to be exact. I'm just putting the reagents back in the cabinet they belong in as I'm working here. that guy off again. I'll need it a little later. May use that weighing boat again. So now we need to dissolve this in a mixture of 5 milliliters of glacial acetic acid and 5 milliliters, or 6 milliliters rather, of 95% ethanol. But we don't have any 95% ethanol in the cabinet. So I'm going to be making some 95% ethanol by taking 19 milliliters of ethanol, 100% ethanol, and I'll also have to make some 50% ethanol for the recrystallization, so that's 19 milliliters of pure ethanol. And then I'm just going to add a milliliter of DI water, and I'll add that by pipette so I don't go over. It's about 1 squirt of water, maybe a little bit more. Get our meniscus where it belongs. I always have 25 milliliter Erlenmeyer flask for sitting pipettes in. And I'll pour that into a beaker just to get it nicely mixed. Swirl that around and just get 6 milliliters. It's pretty close to exact. And then 5 milliliters of acetic acid, and I'm going to measure that out with a pipette. I don't really want to pour that all over the place. These are solvents, so it's not really critical that they be exact quantities. But we might as well get close. Notice I'm setting the Erlenmeyer and pipette next to what it was used to pipette, so I can keep track of what was in what vessel. So now I'll give that a good swirl. I have a glass stirring rod in case I need it to break things up. And I went and got some ice earlier, so I'm just going to put some water in there to make a nice ice bath. And we are going to cool this. Dump it all the way in there. Turn on our stir to about 450. Stir in the middle. And let all that dissolve. I may actually pour a little bit more water out. Plenty of water in there. So we'll let that sit and dissolve. I probably don't need to clamp it. It's only going to be stirring for about 15 minutes anyway. It's very unlikely to migrate off the stir plate. And an extra one of these. So now I'm going to measure out my bleach solution, and I've calculated that I need about 13 milliliters of bleach. I don't want to pour directly from that bottle into a small vessel, so I'm going to transfer some of this bleach, freshly titrated, into a small beaker. And you'll notice it's slightly yellow, and the previous bleach solution was not, so that might have been our first indication that previous bleach solution was no good. Now I'm going to measure out 13 milliliters of this. Pretty close to exact, and the rest of this can go down in clean out the drain a little bit. Sodium bromide's having a little trouble dissolving, so we're just going to leave that for a little longer to try to get that dissolved. And I'm going to break up the one big chunk, improve the surface area a little bit so that it can dissolve completely. And a little stir. I'd like that to go into solution completely. It's a big recalcitrant chunk that really doesn't want to. Maybe should have ground this up in a mortar and pestle before trying to dissolve it. That is a rock. Stay. Always need a damn sponge. So while I'm waiting for that to dissolve, it's going to take a little while, it looks like. I'm going to prepare my quench reagent, and I need a gram of sodium thiosulfate and a gram of sodium hydroxide, but the sodium thiosulfate is rather chunky, and so it takes forever to dissolve. So I'm going to measure that gram out, and I'm going to try to grind it up with a mortar and pestle to get it to a finer powder, so we won't have to wait as long for that to dissolve at the end. The purpose of the sodium thiosulfate is to react with excess bleach. So I just want about a gram of that. And I don't want the huge chunks. There are lots of huge chunks in there. So I got 1.028 grams, it looks like. Call that close enough. 1.025 grams now that it had time to settle a bit. I'm going to pour that into this mortar and pestle. Just grind it up fine. Sodium hydroxide has already been ground. It's the same sodium hydroxide that we use for the aldol condensation, a nice powder. So you see that that's much more powdery now as opposed to the kind of translucent crystals, large crystals that we had before. Should really help that dissolve a lot more readily. And we'll put that back into the weighing boat. So it'll be easy to transfer to the Erlenmeyer flask when we're done. I'll lose a little bit here. It won't come out of that water and pestle readily, but I weigh it out a little bit more than a gram anyway, so we don't need it. And I will use this same spatula for the sodium hydroxide when the time comes to do that. So there's still a little bit of sodium bromide that's not going in. Another bash with the stirring rod. And one large chunk that really doesn't want to dissolve or break up. Progress now. Alright, so I'm going to crank that up to a high speed, like 600 on the stir. And we're going to add the bleach. And for that, I'm going to add the pipette I used for DI. Well, I can use the glacial acetic acid one actually, since there's acetic acid in there anyway. I'm just going to add that kind of dropwise. And you'll see as I do that the solution turns a little bit yellow. That's as the bleach solution oxidizes the iodide to iodine on its way to iodate. NaOCl is going to react with Br- to form NaOBr. Sodium bromide. I think I might have said sodium iodide. I meant sodium bromide. So that's bromine. It's turning kind of yellow-brown in there.